Okay, so this is our fifth scenario using hypothesis testing using a confidence interval. All right, so I included this one just to kind of, give you another way of thinking about hypothesis testing. For the most part, if we're going to do a confidence interval one, we're only going to do it for a single sample. I won't really use a difference one. We actually have like a difference of means, but that might show up on your other final exam. So you should know that when we are looking at a confidence interval for like a two sample test, that they're looking for zero, right? They're looking for the null hypothesis in the middle of the interval. Um, Given that that's the case, let's take a look at this particular one. So we're going to start out. Suppose that you wanted to determine the true proportion of Santa Ana residents that approve a Measure L bond. They survey 1,328 residents and find that 845 of them will be voting for the bond. Okay? So what we've got here, we want to notice, is that 845 is a count, and the question is, will you vote for the bond or not? So this is a categorical variable, right? So categorical variable. And so we're looking at a confidence interval for proportions. CI for proportions, right? The proportion goes with the categorical variable. All right. Now also notice, it says the true proportion of Santa Ana residents. So that's what we're actually trying to estimate. So that's the other thing that you can kind of tell. It's like, oh, you're estimating a proportion. I see. All right. Now, we were going to construct a 95% confidence interval by hand. The critical value for a 95% confidence interval is not, in fact, 1.645. It's 1.96. Whoops. It's a 90% interval would be 1.645. So we're going to actually change that to be 1.96. And what we should see is we're going to just utilize our equation for confidence interval. So our CI, our confidence interval, is going to equal p hat plus or minus z alpha over 2, okay, times the square root of p hat times 1 minus p hat over n. P hat is the sample proportion. And the critical value, in this case, is 1.96. That's z off over 2. N here, okay? So, yeah, there we are. So p hat is going to end up equaling, it's 845, the number of people who said they would vote for it, over 1,328. And the critical value, right, we have, yep, that number, 1.96, z alpha over 2, and n equals 1,328. So now I'm going to go in, I'm going to use my calculator, okay? And the first one I'm going to figure out is I'm going to figure out what is that sample proportion, okay? 845 divided by 1,328. And that's 0.6363. Okay, when I go to 4 decimal places, 0.6363. All right, so this is going to end up equaling p hat equals 0.6363. All right, so my equation, right, I'm going to use my margin of error, which is this piece right here. I'm going to find that first. It's just going to be easier for me to do that. My margin of error is going to equal 1.96 times the square root of 0.6363 times, and then 1 minus 0.6363, which is going to be 0.3637. Okay, let's just make sure that that's case. This one, 3637, great. Divided by 1,328. So let's do that. We get in the calculator. We've got this one here. I'm now going to make it positive. Times 0.6363. So that's p hat times 1 minus p hat divided by 1,328. Then I'm going to take the square root of that. When I find it. guess I'm just going to have to take it to the 1/2. Okay, so that's the square root. And then I'll multiply that by 1.96. And there it is. So it's 0.0259. Okay. Then what I'm going to do is I'm actually going to add and subtract that to p hat. So we're going to have 0.6363 minus 0.0259 and comma 0.6363 plus 0.0259. Okay. And that'll equal 0.6104, comma 0.6363 plus 0.0259, and that's 0.6692, 0.6622, 0.6622. And that's our confidence interval. Okay? So just a little review of how to construct the confidence interval. What I'm most concerned with once you construct the confidence interval is how to think about it afterwards. So we have now, right in the conclusion for the confidence interval, the true proportion. Okay? I am 95% confident that the true proportion of Santa Ana residents who will vote for the bond is 0.6104, comma 0.6622, or is between 61.04% and 66.22%. So somewhere in that region. All right. So now I go back up to my original question, right? You wanted to determine the true proportion of Santa Ana residents that approve the Measure L bond. Well, now ask ourselves, for the bond to be approved, more than 50% of Santa Ana residents have to approve the Measure L bond. Well, did that happen? Well, let's take a look. We've got a 95% confidence interval. That is that we're 95% confident that the true proportion, right, the true proportion who would vote for the bond is somewhere between 61 and 66%. So our evidence here tells us that, in fact, it's more than 50%. 50% is not in the confidence interval. So 50% is not it. In fact, our entire confidence interval is greater than 50%. So that actually tells me that since the bond, or since the CI was completely over 50%, right? The whole thing, right? 61% to 66.22%, totally over, okay? This implies that our evidence, or we might as well just say actually that this, so our evidence suggests that the bond will pass. And that's how we answer that question. If 50% is the bottom end, right, okay, if that's the value that we're looking for, and what we get for the true proportion is completely over 50%, then our evidence says it's not 50%, it's more than 50%. And that's how we use a confidence interval in order to run a hypothesis test. And there we go.